To find sources for Lightning Air Terminal wire, consider these suppliers. Firstly, Cooper Power Systems, which can be found online. Secondly, Airco, also available through their website. Thirdly, GEMC Lightning Protection, accessible via their online platform. Fourthly, Harger Lightning Protection, with details on their website. Fifthly, L.E. Mason, find them at their website. Now let's discuss the difference between braided wire and stranded wire in lightning protection systems. Braided wire is specifically designed for lightning protection applications. It's constructed from multiple strands of copper woven together in a braided pattern. This design offers flexibility and significantly increases the surface area of the conductor. The increased surface area enhances the current carrying capacity, which is crucial for handling the massive energy discharge from a lightning strike. The braided construction also improves the wire's ability to dissipate the lightning's energy. Their stranded wire, while capable of conducting electricity, isn't specifically engineered for the unique demands of lightning protection. It may lack the durability, flexibility, and optimized surface area of braided wire. These factors can compromise its performance during a lightning strike. Therefore, using braided wire designed explicitly for lightning air terminals is highly recommended. Additional important considerations include the following. Firstly, the wire should be made of bare copper. Secondly, it must have a minimum conductivity of 98% International Annealed Copper Standard, often abbreviated as IX. This ensures that the wire offers minimal resistance to the flow of electrical current, allowing for efficient discharge of the lightning's energy. Thirdly, the wire should be sized according to the manufacturer's specifications. Fourthly, adhere to the requirements outlined in the lightning protection system design. Correct wire sizing is critical for handling the expected current load and ensuring the effectiveness of the entire system. Fifthly, proper installation techniques are paramount. This is crucial for guaranteeing the overall effectiveness of the lightning protection system. A poorly installed system, even with high-quality components, can be ineffective or even dangerous. Ensure that all connections are secure and properly grounded, and that the wiring path is as direct as possible to minimize impedance. By choosing the right type of wire, adhering to conductivity and sizing guidelines, and employing proper installation practices, you can significantly enhance the safety and reliability of a lightning protection system. The selection of appropriate wire is important. The difference lies primarily in their design and suitability for handling the immense energy of lightning strikes. Braided wire offers superior flexibility, increased surface area, and enhanced current carrying capacity compared to standard stranded wire. This makes it the preferred choice for lightning protection applications. Remember to always consult with the manufacturer's specifications and relevant industry standards when selecting and installing lightning protection components. This is also important for safe installation and performance. Always prioritize safety when working with electrical systems, especially those designed to handle lightning strikes. If you are not experienced in lightning protection system installation, it is best to consult with a qualified professional. Professional installers have the knowledge, skills, and equipment necessary to properly design and install a system that meets all applicable safety codes and standards. It is also important to consider the local climate and lightning activity when designing a lightning protection system. Areas with high lightning frequency may require more robust systems than areas with less frequent lightning strikes. The cost of a lightning protection system is a small price to pay for the peace of mind that comes with knowing that your property and occupants are protected from the dangers of lightning. Besides the selection of appropriate wire, its conductivity and size, a critical aspect of lightning protection systems is the grounding system. The grounding system provides a low impedance path for the lightning current to safely dissipate into the earth. A well-designed and properly installed grounding system is essential for the effectiveness of the entire lightning protection system. The grounding system typically consists of ground rods, ground plates, or a combination of both. These grounding electrodes should be installed deep into the earth, below the frost line, to ensure good electrical contact with the surrounding soil. The number and spacing of grounding electrodes will depend on the soil resistivity and the size of the building being protected. It is important to consult with a qualified lightning protection system designer to determine the appropriate grounding system for your specific application. In addition to the grounding electrodes, the grounding system also includes the grounding conductors, which connect the air terminals, down conductors, and other components of the lightning protection system to the grounding electrodes. The grounding conductors should be sized according to the manufacturer's specifications and the requirements of the lightning protection standard. They should be installed in a direct and unobstructed path to minimize impedance. Proper bonding of all metallic components within the building is also important to prevent side flashes and potential damage to electrical equipment. Bonding involves connecting all metallic components such as pipes, conduits, and metal frames to the grounding system to create a common ground potential. This helps to equalize the voltage potential between different metallic components and reduces the risk of electrical arcing. Surge protection devices, also known as SPD, are another important component of a comprehensive lightning protection system. SPD are designed to protect sensitive electronic equipment from voltage surges caused by lightning strikes or other electrical disturbances. They are typically installed at the service entrance of the building and at various points throughout the electrical distribution system. SPD work by diverting excess voltage to ground, thereby preventing it from reaching and damaging connected equipment. There are different types of SPD available, each designed for specific applications and voltage levels. It is important to select SPD that are appropriate for the equipment being protected and the electrical system in which they are installed. Regular inspection and maintenance of the lightning protection system are also essential to ensure its continued effectiveness. The system should be inspected annually or after any significant weather event, such as a lightning strike or a severe storm. The inspection should include a visual examination of all components, including air terminals, down conductors, grounding electrodes, and SPD. Any damaged or corroded component should be replaced immediately. The grounding system should also be tested periodically to ensure that it is providing adequate grounding. This can be done by measuring the ground resistance using a ground resistance meter. If the ground resistance is too high, additional grounding electrodes may be required. Maintaining proper records of all inspections, tests, and maintenance activities is important for tracking the performance of the lightning protection system and identifying any potential problems. A well-maintained lightning protection system can provide reliable protection against the dangers of lightning strikes and help to ensure the safety of people and property. Always remember to prioritize safety when working with electrical systems. If you are not experienced in lightning protection system installation or maintenance, it is best to consult with a qualified professional. Understanding the components and principles of lightning protection systems is important for ensuring the safety of buildings and occupants in areas prone to lightning strikes. The air terminals, often called lightning rods, are the first point of contact for a lightning strike. They are typically installed on the highest points of a building, such as the roof, chimneys, and antennas. The purpose of air terminals is to intercept the lightning strike and provide a safe path for the current to flow to ground. Air terminals are typically made of copper or aluminum and are designed to withstand the high temperatures and forces generated by a lightning strike. They should be installed in accordance with the manufacturer's specifications and the requirements of the lightning protection standard. The down conductors are the pathways that carry the lightning current from the air terminals to the grounding system. They are typically made of heavy gauge copper or aluminum wire and are installed along the exterior walls of the building. The down conductor should be installed in a direct and unobstructed path to minimize impedance. Sharp bends and loops should be avoided, as they can increase the impedance and reduce the effectiveness of the lightning protection system. The number and spacing of down conductors will depend on the size and shape of the building being protected. The grounding system is the final destination for the lightning current. It consists of grounding electrodes, which are buried in the earth, and grounding conductors, which connect the down conductors to the grounding electrodes. The grounding system provides a low impedance path for the lightning current to safely dissipate into the earth. A well-designed and properly installed grounding system is essential for the effectiveness of the entire lightning protection system. The selection of materials for a lightning protection system is crucial for its long-term performance and reliability. Copper and aluminum are the most commonly used materials for air terminals, down conductors, and grounding conductors. Copper is an excellent conductor of electricity and is resistant to corrosion. Aluminum is also a good conductor of electricity and is lighter and less expensive than copper. However, aluminum is more susceptible to corrosion than copper, especially in coastal environments. When selecting materials for a lightning protection system, it is important to consider the environmental conditions and the potential for corrosion. In corrosive environments, it may be necessary to use corrosion-resistant materials or to protect the materials with a coating. The installation of a lightning protection system should be performed by a qualified and experienced contractor. The installation should be in accordance with the manufacturer's specifications and the requirements of the lightning protection standard. Proper installation techniques are essential to ensure the effectiveness of the lightning protection system and to prevent damage to the building. The contractor should also be familiar with local building codes and regulations. Before installing a lightning protection system, it is important to conduct a thorough site assessment to determine the potential lightning hazards and to design a system that is appropriate for the specific building and site conditions. The site assessment should include an evaluation of the building size, shape, construction materials, and occupancy. It should also consider the surrounding terrain, the presence of nearby trees or structures, and the local lightning frequency. The design of the lightning protection system should take into account all of these factors to ensure that the system provides adequate protection against lightning strikes. The maintenance of a lightning protection system is important for ensuring its continued effectiveness. The system should be inspected annually or after any significant weather event, such as a lightning strike or a severe storm. The inspection should include a visual examination of all components, including air terminals, down conductors, grounding electrodes, and connections. Any damaged or corroded component should be replaced immediately. The grounding system should also be tested periodically to ensure that it is providing adequate grounding. Proper documentation of the lightning protection system is essential for tracking its performance and identifying any potential problems. The documentation should include a detailed description of the system design, including the location of all components, the materials used, and the installation methods. It should also include records of all inspections, tests, and maintenance activities. This documentation can be used to track the performance of the system over time and to identify any potential problems. By following these guidelines, you can help to ensure that your lightning protection system provides reliable protection against the dangers of lightning strikes. The National Fire Protection Association, often abbreviated as NFPA, Standard 780 is the standard for the installation of lightning protection systems. This standard provides detailed requirements for the design, installation, and maintenance of lightning protection systems. It covers all aspects of the system, including air terminals, down conductors, grounding electrodes, and surge protection devices. It also includes requirements for the selection of materials, the installation methods, and the testing and inspection procedures. The NFPA 780 standard is widely recognized and adopted by building codes and regulations throughout the United States. It is essential for anyone involved in the design, installation, or maintenance of lightning protection systems to be familiar with this standard. The Underwriters Laboratories, often abbreviated as UL, also provide standards for lightning protection system components. These standards cover the performance and safety of air terminals, down conductors, grounding electrodes, and surge protection devices. UL-listed components have been tested and certified to meet the requirements of these standards. Using UL-listed components can help to ensure the quality and reliability of a lightning protection system. In addition to the NFPA and UL standards, there are also other industry standards and guidelines that may be applicable to lightning protection systems. These standards may cover specific aspects of the system, such as the grounding system or the surge protection devices. It is important to be familiar with all applicable standards and guidelines when designing, installing, or maintaining a lightning protection system. A properly designed, installed and maintained lightning protection system can provide reliable protection against the dangers of lightning strikes. It can help to protect buildings, occupants, and equipment from damage and injury. The knowledge of lightning protection systems is crucial for ensuring the safety of structures and individuals in areas prone to lightning activity. The principles of lightning protection involve creating a safe path for lightning current to flow to ground, minimizing the risk of damage and injury.